These problems come from the combined like terms section of Delta Math. It is under the Algebra 1 section of polynomial operations. So I do recommend multiple colors for this just to make it a little bit easier. If you don't have that, it's okay. I'll show you a technique that you can use in case you don't have lots of different colors like I do. So our strategy for combining like terms is to first identify what like terms are. So remember that for terms to be like terms, they need the same variable and the same exponent as well. So my first step is to identify like terms, and this is where my colors are going to come in. So I'm going to start with my first term, and my first term has a y squared. So I'm going to go ahead and use this color to identify that term. Then I'm going to go through and look for terms that also have y squared as part of them. So 6y squared is a like term. And if you are identifying like terms, make sure that you include that sign. That's going to let you know what operation to use when combining your like terms. It looks like I have one more that will go in this set. That would be 3y squared. 5y and 4y, although they include the y, they don't have that exponent of 2, so those are not like terms. All right, I'm going to switch colors because I'm switching the like set of like terms that I'm working on. So I'm going to go to my next unpaired term. Looks like I have a 5y. And looking at my other options, I have 4y, 3, and a -1 here. So it looks like the 4y is going to be what combines with my 5y. Looking at my last two terms, I have plain numbers, which does give them the same variable, aka no variable, and the same exponent, no exponent, which makes them a match. So I have a +3 and -1. We did get kind of lucky on this problem that everything's kind of sectioned off into like terms. Unfortunately, not all problems work that way. Now is where the combining part actually comes into play. So I'm going to start with my first set of terms. Now remember, when you combine like terms, you only add or subtract those coefficients. You do not add or subtract the exponents. If you do not see a coefficient on one of your terms, like this leading one right here, that is a 1. And if it helps to write those ones in, you are more than welcome to do that. So -1 plus 6 is going to make 5, and 5 plus 3 is going to make 8. So I will have 8y squared coming from those blue terms. Looking at my green set of terms, I have a +5y plus another 4y, which will make a +9y. The positive is going to dictate the plus sign there in the middle, so plus 9y. And last but not least, I have one more set of terms to combine, a +3 and a -1. So +3 minus 1 will make a +2. Just to make sure, if I look through the terms that I have left, none of these terms are like terms, so it means that I've combined everything that I can and makes this my final answer. Now, if you don't have colors, it's okay. You can use either shapes or different styles of lines to also identify your like terms. Just make sure again that you include the sign with what your term as you mark them. So I'm going to start with this first one. I'm going to do a plain underline with this one. So we have -2x to the third, and then I look through to see if I find any other x to the thirds. Ooh, right here. So I'm going to underline starting at the plus sign all the way underneath that term to let myself know that those go together. It looks like I don't have any other x to the third, so I'm going to move on to the next set of terms here. So it looks like I have x's. I'm going to use arcs under this one. Okay, looks like these are the two terms that will go together in that pair. And then I have these 3 plain numbers in the back, which are also going to go together. So I'm going to use dotted lines for that. Notice on this problem, our terms are a little bit more mixed up. So I'm going to go ahead and combine. I'm just going to start with the first things that I see, starting with that leading pair. So I have -2x to the third plus 7x to the third. It's going to make a +5x to the third. Okay, again, that came from my underlined terms. Now, in my next set, I have a +3x minus 3x, which should make 0x. If you get something like 0x, you do not write 0x in your problem. You just leave it out. These two terms cancel each other out. So that's going to allow me to move on down to this set back here, where I have 1 plus 2, which will make 3, and 3 minus 5 will make -2. Because it's negative, I'm going to join those two terms with a minus sign. And that came from my dots. All right, that makes this my final answer. Okay, only one more different thing to show you. If I identify my like terms first, I'm going to kind of combine those strategies. So I have different x to the third. So we have 4x to the third, negative 3x to the third, and another positive 4x to the third back here in the back. I have some plain numbers. I have positive 3. I have negative 3. And I have a positive 4. Now it looks like I just have this single 2y squared back here in the back that doesn't fit with any of my other groups. So again, identifying, looking for things with the same variable and the same exponent. So now we're going to combine our coefficients. We have negative 4x to the third minus 3x to the third, which will make negative 7x to the third. And then we're adding back another 4x to the third, which should leave me with negative 3x to the third. You may also notice that here you have the negative 4x to the third and positive 4x to the third, which would cancel each other out. In the green section, I have positive 3 and negative 3, which also cancel each other out to make 0. And 0 plus 4 will just be a positive 4. The last thing that I have is this lone 2y squared. I don't have anything to combine it with, so it just drops down into our final answer. Okay, I have no other like terms in my problem, and that makes this the end of that example.